And hello. Today we'll be looking at solving equations. I highly recommend that you look at the fundamentals of equations video before looking at this, just so you have a clear understanding of what an equation is and the rules involving an equation. So we'll get straight into it. We're looking at finding the unknown. So let's say we have x plus 9 is equal to 12. Now just a little quick recap on all the terminology. We have the variable. So x would be the variable in this equation. It's a thing that we don't really know, and it can vary in different equations. So this is one particular equation where we have an x in it. Then we have constants, which are just numbers. So 12 would be a constant, 9 would be a constant, x is not a constant, it would be a variable. Now in other equations we might have two variables, so we might have x, we might have x and y, we might have a and b, c, all different types of letters, but they would always be variables. So the question is, we want to solve the equation, but what do we actually want? Well, we're looking for the unknown. So what is the unknown? We know what 9 is. We know what it's 12. What's x? We want x equal to something. I want to know, well, x is equal to some number so that it solves this equation. What do I mean by solve? Do you remember in the fundamentals lesson we were talking about how balancing an equation always has to be balanced? What that means is the left-hand side has to be equal to the right-hand side. So what I'm actually asking is, what number do I put in for x to make the right-hand side and the left-hand side equal to each other or balanced? And we're going to find out how to do that. Now you probably could do it in your head, but I'm going to show you how we actually do it kind of step by step. So what do we want? We want to end up with x equal to something. So the question is, how do we isolate x? Now this is a really important word to remember. Isolate, you'll see it a lot throughout the course. Isolate just means we want something by itself on one side of the equation equal to everything else on the other side. So I isolate x means just x equal to something. So isolate, be by himself. So during COVID we were all isolating, which means we were by ourselves. So how are we going to do that? Well, this is what we're going to do. I want x is equal to something. I don't want x plus 9. I want to get rid of this plus 9. So how am I going to do that? Well, this is what I'm going to do. Remember, with our fundamentals lesson, I can add and subtract numbers from both sides. And if I do the exact same thing to both sides, it's still balanced. So I'm subtracting 9 from this side. Now, why did I choose to subtract 9? What's plus 9 minus 9? Well, it's 0. They just cancel each other out. Plus 9 minus 9, 0. So I'm going to get rid of this 9 by subtracting 9. Now, that's fine, but whatever I do to the left-hand side, I have to do to the right-hand side. So I also have to subtract 9 from this side, 12 minus 9. Okay, so now I'm left off with x is equal to 3. Because 12 minus 9 is 3. And that's what I wanted. I wanted x is equal to something. I have x is equal to 3. So that means if I put in 3 instead of x into this equation, it should be balanced. So let's check. Let's check that we were right. So if I put in 3 instead of x, I have 3 plus 9 is equal to 12. Is that correct? Well, yeah, it is. 3 plus 9 is equal to 12. 10, 11, 12. So this is how we'll be solving equations systematically, not just guessing. First off, we want to isolate x. So we want x is equal to something. Then when we have a final answer, we can check it just to make sure that we're right. So, what about this one? 2x minus 5 is equal to 7. A little bit more tricky, especially if we were trying to just plug in numbers, so substitute numbers. So if I tried x equal to 1, x equal to 2, I might be there for a little bit. But we're going to do the exact same steps. So, what do we have? We have variables. We have x is a variable. Now this time we have a coefficient. So remember, a coefficient is just the number in front of x, and it's multiplying x. So this is 2 times x. That's what a coefficient is. And then we have our constants. We have a minus 5 and a 7. So what's our end goal? What do we want? Exactly the same. I still want x is equal to something. I want to put in a number for x, and then this equation should be satisfied, should be balanced. So how do we do that? Well, we need to isolate x. Exact same steps as last time. So I have a 2x minus 5 is equal to 7. I don't really want this minus 5. I'll worry about the 2x in a second. But I don't want this minus 5. Now what am I going to do? I want minus 5 to go to 0. So how would I do that? Do I subtract 5? Well, no, I don't actually. In this case, I'm going to add 5. Because minus 5 plus 5 is equal to 0. So they'd cancel. And remember, whatever I do to the left-hand side, I have to do to the right-hand side. So now I have 2x is equal to 7 plus 5. So 2x is equal to 12. Now, am I finished? No. Because I want to find x is equal to something. I have 2 multiplied by x is equal to something. So how am I going to get rid of the 2 multiplied by x? I want just x. Well, if I divide by 2, because I can do that, we can multiply and divide both sides, that's fine. If I have 2x divided by 2, well, what happens if I'm multiplying something by 2 and I divide it by 2? Well, they just cancel each other. I just get x. Think about it. If I have 3 multiplied by 2, that's 6. But if I then divide it by 2, then it's just 3. I just go back to the same spot. So I'm going to divide this side by 2, because then I just get x's by itself. Remember, if I do something to the left-hand side, I have to do it to the right-hand side. So I'm going to divide 12 by 2 as well. Then I get x, because 2x divided by 2 is just x. And I get 12 divided by 2, which is 6. Do I have a final answer? Yeah, I do. I have x is equal to 6. So then I have to go and check my answer, same as last time. So instead of x in this equation, I'm going to put 6. So I have 2. Again, what do the brackets mean? They're just multiplying. Minus 5 is equal to 7. So what's 2 times 6? That's 12. Minus 5. 12 minus 5 is 7. So this left-hand side is 7. The right-hand side is 7. We're balanced. We've solved the equation. So just a little important note. You must isolate the x terms first. What do I mean by that? Get the x's by themselves. So get rid of all the constants. So there was a minus 5 here. I just want the x's on one side and the constants on the other side. Then I can find the x by himself. And I have to worry about the coefficient then. So, what about this one? Minus 3x minus 5 is equal to 7. So we have our variable, we have a coefficient, and we have constants. Coefficients this time is minus, so we might have to worry a little bit about that. Okay, what do we want? We want x is equal to something. How do we do that? We isolate x. First off, I don't want this minus 5. I want to get rid of the numbers. I want x's on one side, numbers on the other side, or variables on the one side, constants on the other side. Minus 5, if I add 5 to it, it's going to go to 0, so it's gone. So I'm going to do the exact same thing to both sides. Plus 5, plus 5. Then I'm left with minus 3x is equal to 12. Now, tricky part. I want to get rid of this. I'm minus 3 multiplied by x. That's what this means, is equal to 12. I don't want this minus 3. I just want x by himself. So that's going to be 1x. So how am I going to do this? Well, very similar to last time. I'm just going to divide. But this time I'm dividing by minus 3. Because minus 3 divided by minus 3, well, that's just going to be equal to 1. Yeah? Minus 3 divided by minus 3, that's just 1. If I divide any number by itself, it's 1. 10 divided by 10 is 1. Minus 4,000 divided by minus 4,000, it's 1. So I'm going to divide it by minus 3. That gets me to 1x, which is what I'm looking for. Now, whatever I do to the left-hand side, I have to do to the right-hand side. So I'm going to divide this side by minus 3. Then I get x by himself, 12 divided by minus 3, positive divided by a negative is going to be a negative. You might have to refresh yourself on multiplying and dividing by positives and negatives. So I get x is equal to minus 4. So we got an answer. Let's go and check it. Minus 3 times minus 4, minus 5. So what's minus 3 times minus 4? Well, that's going to be plus 12. Minus 5, so 12 minus 5 is 7. Okay, so the left-hand side is 7. Right-hand side, well, it's 7. We're balanced. We're okay. We've solved the equation. X is going to be minus 4. Okay, last example. Tough one now. We have variable, coefficient, constant. This time, you'll notice that the coefficient is a fraction. We'll come to that in a minute. What do we want? We want x equal to something. We want x by itself. We want to isolate x. Okay, starting off, I want to get rid of this plus 3. So I'm going to subtract 3. Because plus 3 minus 3, they cancel. 7 minus 3 then, because whatever I do on the left-hand side, I have to do to the right-hand side. Then I get a third of x is equal to 4. Now, this is the tricky part. I don't want a third of x. I want just x. So think about it. Imagine x is a full x, and I've divided it into 3 bits, and now I'm only looking at a third of x. So how am I going to find just x by himself? Well, if I multiply, because remember we can multiply as well, if I multiply a third by 3, what happens? Well, a third multiplied by 3 is just going to be 1. Yeah? So I'm going to get 1x over here if I multiply by 3. And whatever I do to this side, I have to do to this side. So I'm going to multiply this side by 3 because then I'm just going to get 1x. If I multiply this side by 3, I have to multiply this side by 3. So 4 3s are what? Well, it's 12. So I have x equal to 12. What we're going to do, we're going to check our answer. What's a third of 12 plus 3? Well, a third of 12 is 4. Plus 3 is 7. So we got the right answer. So in the cases of fractions, we want to maybe multiply it by whatever number we can think of to try and get it to 1. And we look there, you'll probably see more difficult examples later on. But just remember, if I have a fraction, I might need to multiply it by something.